This is lesson 17. In this lesson, we will be moving from rates to ratios. The lesson summary says, a rate of 2/3 gallons per minute corresponds to the unit rate of 2/3 and also corresponds to the ratio 2 to 3. All ratios associated with a given rate are equivalent because they have the same value. So lesson summary it is showing that relationship between fractions and ratios, which is something we've worked on, and this lesson will continue to work on. In this problem we have, it says Dave can clean pools at a constant rate of 3/5 pools per hour. To break that apart and dissect what it means, it's saying in 1 hour, because we see that sign, that dash sign, meaning per. So per 1 hour, he can clean 3/5 of a pool. Now, we need to use our understanding of what fractions are telling us. This question says, what is the ratio of the number of pools to the number of hours? We can express ratio in a ratio table. And if we're comparing, as the question asks, the number of pools to the number of hours, what is the ratio? When we break this apart, it seems like it's a ratio of 3/5 to 1. But also, no, and this is something that we continue to talk about, fractions are ratios. So what it's really saying is that in 5 hours' time, he could clean 3 pools. And this is showing us that he is cleaning 3 pools at 5 hours, which is the same thing as that 3/5 to 1 hour rate. And knowing that this is meaning 3/5 in 1 hour. And that's where the only tricky part of this lesson comes in, is knowing that relationship between fractions and ratio. And that if you're given a fraction, that is telling you the ratio. So 3/5 is telling you it's a rate of 3 to 5 of pools per hours. Now, using that information, how many pools can Dave clean in 10 hours? So if we go back to our original ratio of pools, hours, 3 pools in 5 hours, well, to get to 10 hours is not so difficult. Some people might also choose to solve this type of problem in a tape diagram. 1, 2, 3, 1, 2, 3, 4, 5. And if the hours are equal to 10, then each box would be equal to 2, which is the same thing in the T-chart. We're just going to be multiplying by 2, and whatever you do to one side, you must do to the rest. And he can clean 6 pools in 10 hours. And just off to the side, I want to just make a quick point to talk about, now that you have a developed understanding with ratio, what the difference would have been if you tried to solve this several weeks ago. Before we started a ratio unit, you might have looked at something like this and written out the original ratio is pools are 3/5 and hours are 1. And then to get to 10, it's much more difficult to be working with fractions in your table. That's why we want to represent those fractions as ratios within our table. Just as a general aside. So the answer to that question was 6. We just multiply by 2. Not a difficult question. The following question, how long does it take Dave to clean 15 pools? Once again, our original ratio table. I want to use black. Of pools to hours. And it's at that 3 to 5 rate, 3 pools to 5 hours. How long does it take them to clean 15 pools? So that tells us we're working on the other side of our table now to get to 15. And same thing if you were using a tape diagram of pools to hours. Our pools are now equal to 15, so each box is equal to 5. Same thing in our table, we're just multiplying each side by 5, and the hours would be 25 hours, or we could also express that if we wanted to as 1 day and 1 hour. Also not a tricky concept. We've worked with this stuff in other lessons as well. Our final question says simply express the unit rate as a decimal. So we're given that unit rate of pools hours in a 3 to 5 relationship. To express that as a decimal, we want to get rid of what we could say is the denominator, which would be this, or the number of hours we want to make 1, so we can just give that rate. So essentially we're just dividing by 5. To do 3 divided by 5, I'll do it in blue off to the side. 3 divided by 5. 5 goes into 3 0 times, so it's a number smaller than 1. So we're going to add a decimal. 5 goes into 30 6 times, and there's 0 remaining. So the rate can be expressed as 0.6 pools per hour. So altogether, not so challenging. I think you'll be comfortable working with this as long as you remember fractions are ratios. Ratios are fractions, as well as everything else.